Okay, we've been discussing why when we throw things at the window, such as a paper wad, why does it not break? And then I throw a baseball at the window, and it does break. So you can also zoom in and out with this button here. I don't know, you can fool with it.
Oh.
Is this a new? Can I tell them about the homework?
Yes.
All right, this is our homework for this weekend. I'll be introducing this mod, and you'll be reading and taking notes on a concept called impulse. Don't read the green experiment, just read around it on impulse, take notes, and that's all you have to do, no problems this weekend. Mod 9, the reason why the paper wad does not break the window and the baseball does is a concept we're going to explore. Momentum. Is momentum a word that you use in your everyday lives? Does anyone you use it from time to time, or are people?
Well,
All right.
what if I remember to use it?
All right. So, do you have enough momentum to finish this quarter since it ends at 2:30 today?
Yep.
Okay. All right. Some of you don't. So, all right. You're lacking momentum. So momentum is a word that you probably have experienced in everyday life, and we're just going to come alongside of it and put in some mathematical terminology. The letter that represents momentum is not M, and O was taken, and M was taken, N was taken, and O was taken, so P. Momentum is P. It stands for momentum. The equation for P is mass times velocity. That's all there is to it. I wrote the words out, but normally I'll just write MV. So that is the deep, dark, beautiful equation for momentum. Mass times velocity. Let's explore the units. If you know the unit for mass and the typical unit for velocity, you can multiply them together and get the unit for momentum. What is it? Anyone? Molly, what's mass normally? What's the unit for mass normally? Kilograms. Sorry. And what's the unit, Molly, for velocity? So you put those together and you get a kilogram meters per second. It has not been renamed, so we're stuck with it. Maybe when you get famous, you can hook your name to it. If you break enough windows, we'll name it after you. Kilogram meters per second is the unit for momentum. I apologize, it's not some cutesy little name like Joule, but it's not. So, kilogram meters per second is as good as it gets.
I said that before.
All right. Questions so far on the momentum? All right, let's go on and I thought I saw something out here. There are two dogs, and they're the same mass, but they have different momentums. There are two dogs moving out there, and they have the same mass. What could it? But they have different momentums. Explain how that is possible. I saw two dogs. They're out there. They're moving. They have the same mass. Twin dogs. Can you believe it? How could they have different momentums? Your idea.
They're moving at different speeds.
Right, because there's a combination of mass and velocity. I said they were moving. I said they had the same mass, but I didn't mention the speeds. So if their momentums were different, this must be different. All right, let me look again. Oh my gosh, not only are they the same mass, they have the same velocity. But guess what? They have different momentums. How could this be?
Yeah. What mass?
Two dogs, same mass, same velocity, but different momentums.
Is one of them on bars?
Does one
No.
have a different time?
Nope, time is not involved here. All right, I haven't set you up to answer that problem, so let me set you up now. It turns out because v, velocity, is a vector, remember in your book they make them real dark, and I think I I had a symbol I used to use way back when. Was it like a little hat, a line over the top, something like that? I don't remember. All right. Somehow, your teacher and your text, every time you use velocity, it should be indicated with a emboldened V because it's a vector. A vector has two parts. Do you remember what they are, Alex? Either part of a vector? Magnitude is one, magnitude and
Longitude.
and what? What'd you say?
Nothing.
Okay.
That's
All right. Magnitude and Alex, anything? Huh?
Angle.
Angle, direction, as I'll write it, but that's the same thing. So, it turns out if this is a vector and all I did was multiply it by a number, do you need me to stop?
No.
Okay. And so this is also a vector. So therefore, let me say it again. Oh my goodness, two dogs outside, same mass, same velocity, but different momentums. How can this be? Now that I set you up, Morgan, an idea?
They're going in different directions.
Right. Direction is involved with momentum. So every time I give you an answer for momentum, I should indicate a direction. I probably won't, but I should say, if this is going in the southwest direction, so is this. So whatever direction your velocity is in, momentum will be the same. So let's make a note of that. Direction of momentum and velocity are the same. All right. Does that show up?
Yeah.
Okay, good enough. All right. Let's do an example problem. I have a problem, you have a problem. Let's have someone else do it. You guys have been sitting down too long. So,
You mean someone else writing on the board?
yeah. All right. If, Aaron, we'll start with you, we'll go around, everyone will get their chance. I want you just to do part of this problem. So, she'll be the
Aaron,
artiste.
girl.
Wait,
Aaron, you're gonna be in the.
Aaron, close up on your face.
Pardon?
Aaron,
No, don't do that.
All right.
Hey, Aaron.
Draw a car.
How was your
Aaron,
day?
you're gonna be famous.
I don't draw good cards. This is gonna be.
Well, you gotta be better than, that's fine.
Oh, oh.
Oh,
Leave me alone.
Draw a car. Everybody, draw your card. You're taking notes on this problem.
John.
That's
What did he
perfect.
say?
John just called it a cow.
345 kilograms. Write that on your paper.
45.
345. And the velocity of the car is 19.1 meters per second southwest. So just add a SW. And the question is, find P, find momentum. Have a seat. Morgan, going up.
Oh yay.
And write down the equation for momentum. I'll
Don't
read
touch
it
the
to you if you've
camera.
forgotten.
Oh, jeez.
It's P equals MV. And put the numbers in, and we'll have, who has a calculator out? Jonathan, if you would tap it out for her. She doesn't have her calculator up here.
What am I? Wait, what?
She'll tell you what the numbers are.
Oh.
Is it a really big number?
All right, wait for, Morgan, wait for the answer.
6,589.5. So that's
589.
that's 6,589.5.
All right, Matt, Morgan, put that in 3 sig figs.
Would that be it? Anyone?
Yeah.
No.
You should do five.
Oh,
six,
yeah, yeah, sorry,
6.5.
sorry. I was thinking it would have
No,
like
he
3
said,
zeros.
or she said that it's 360.
Yeah.
Yeah, it is 3 sig figs, isn't it? We didn't use 9.8 for once. Okay. All right,
like
so
11.
Whatever happens.
given the mass and velocity, we were easily found the momentum by multiplying What would the unit be, Morgan?
Kilogram meters per second.
All right, so add the units. Does that ring a bell? Do you remember what a Newton was? A Newton, just in case it helps later, is a kilogram meters per second squared. So it's pretty close, pretty
Can I
close.
just find Newton?
So, all right. Let us go on then, and we'll have a chain of students come up and develop the next equation. And that'll set you up for your reading this weekend.
Is it the force equals impulse, or not impulse, momentum over change in,
Yeah,
or
we're
change
gonna
in
be
momentum?
developing that, yes. All right, so Hannah, up front, and would you write Newton's second law? Do you recall what it is? And it's just an equation.
Do you think, oh, yeah. Is that right?
No, it's not.
Right. All right, you can stay up for a little bit.
Okay.
All right. Somebody tell us, so she can write it, the definition for acceleration. We actually used it when we did our vanilla set 1. It's going to be change in something divided by change in something.
That's changing time over.
Time is in it, but it's the bottom.
Changing.
Can I just write it if I know it?
The thick fell
Changing
off.
velocity.
It's
Yeah.
delta V
All right,
over
very
delta
good.
T.
Jonathan, got it? So, as she develops this for a while,
Just write it over here.
I would like you to also write this development.
Oh, I think I already wrote
Oh,
it
wait,
from
hold
the
on.
reading.
Okay.
Should I
all right.
rewrite it?
No,
Okay.
you can just watch it then. All right. Now where's your M? Okay. All right.
And is the change in time
Now
just
we'll
change
just
in
call
time?
it change in time because time is.
No, what is that? Oh, that's change.
All right. She has taken change in velocity. Whenever there's a change, you have to start with something and end with something else and find the difference. That's how you find change. So velocity final minus velocity initial is the same as change. So she replaced that, and now she's distributing the M. But we just learned that MV and MV are called momentum. So PF minus PI.
PI or PI?
Or oh. All right, and so we can call
To
that
that.
change in momentum. Yeah, that's it. Very good.
Oh, no, my
All right.
phone's green.
For those who had already started our reading, you will see this development again, and it should make sense having gone through it in class. F equals ma, we replaced a with the definition of acceleration. Change in velocity is the same as the
crap.
final minus the initial.
Are you over?